Hello. In follow-up to a video we released recently showing how to create a telemetry component for MetaTrader 4, we received a comment asking to do the same thing for MetaTrader 5. Now, the telemetry component is intended to allow you to record information through the VPS MetaTrader and to view it then on your client computer without needing to log into the VPS, because logging into the VPS, obviously it's a problem to do that on a repeated basis, and there's always the chance that you will cause problems with any expert advisors you have running on the VPS. So by using the telemetry component, we can display information on a client. So the telemetry component itself simply transfers information between the server and the client, and you need to incorporate that into the experts that you write to save information, and then you can create something on the client to use the telemetry component again to retrieve that information. So as I said, we created this video a short time ago, and I'll leave a link to that. And it was specifically for MetaTrader 4. And then we had this request to update for MetaTrader 5, which at first seemed like a trivial issue, but then the more we thought about it, there are some issues that we faced in converting to MetaTrader 5. Nothing difficult. And as you'll see as I do the demonstration, if we cut the telemetry component and its associated classes to the bare minimum needed to do telemetry, there are literally only 4 lines of code that need to be modified, and those 4 lines of code are completely compatible between MetaTrader 4 and MetaTrader 5. But because I had included some standard components and functions, those components and functions weren't necessarily compatible, but I can make them compatible. So what I'm setting about here today is to recreate the MetaTrader 4 code and then convert that and make sure that it can run on MetaTrader 5, and show how to maintain compatibility between both, so that at the end of this, the same code for the telemetry components can be run on MetaTrader 4 and MetaTrader 5. And the only change you would need to make is that any experts or indicators that you create would need to be renamed from MQ5 to MQ4. The telemetry component itself is basically a storage container that's responsible for maintaining a list of values and writing that information to a file and retrieving it from the file. Then the values that are being stored there are maintained as KeyValue Pair, or objects of the KeyValue Pair class. So let's get started, and we'll look at the KeyValue Pair class first. Let's start with the KeyValue Pair class. I'll just scroll this down. Now, every piece of information that we want to send from the server to a client has a key and a value. So the key is simple enough, it's just a string, but the value is a little more complicated because I want to be able to store any type of data in here. If I simply declared an M value of type string, then I can only store strings. If I declare it as a type int, I can only store integers. Now, I could try templating this. I could add a template type name T and then declare my M value as, but that creates some problems, and I'll just move over to this script that I have to demonstrate the problems that creates. Now in this script, I've just added a class of type C pair. I've templated it with template type name T, and I have a key string and a value of type T. So this is a perfectly valid class. If I comment this line for a moment, I can compile that, no problems. If I try to create an object of type C pair, then I will get a compiler error, because this class is now templated. Every time I create an instance of it, I need to declare this type. So I can get around that with something like this. I can declare that I can say that I'm creating an integer type, and that compiles. And then I can assign the key to that, and I can assign a value. No problem so far. But I want to be able to store any types of values in here, and I want to be able to reuse the keys for new value types. So if I now try to store a string, I get a warning from the compiler, and that means that at runtime it's going to be converting data types, and that can result in values that I don't want stored. So I need something that's better than just relying on this implicit conversion from different data types, and that means that I can't use this templating. So let's go back to the code. So what I've done to resolve that problem is set up the value as an object of type KeyValue Pair value base. So let's look through what I've done to create that. So here I have a class called KeyValue Pair value, and I inherit from KeyValue Pair value base. And this is where most of the work is done. This is a templated class, so I have a type name of tValue, and the one variable I'm storing in here, mValue, is of type tValue. So I can store anything inside this class now. And using this templating does create similar problems to the ones I just demonstrated, but by including it here with this base class, I'll show you how I'm able to work around those problems. Firstly, I've got the constructor, KeyValue Pair value, simply takes a value of type tValue and reassigns to the internal variable. Easy. I want to be able to retrieve the type name. That's a simple function that just gets the type name of the internal variable. I want to be able to get the value, and I'm returning a value of type tValue, and all that does is a simple return of the mValue variable. And then I want to convert this to a string, which I need for serialization. If I'm going to store this to send it to a remote machine, I need to be able to convert everything to a string. So I have a toString function which returns toString passing in mValue, and you'll see there's no toString that takes an argument here. So I have defined the toString functions that take values in the base class. Here's the base class. First, my virtual type name function and the toString function taking no arguments, which I've overridden then in the KeyValue Pair value class. And then I have 5 toString functions, each one taking a different type or different data type. So there's the string, long, double, date, time, and then this void, which I'll get to in a moment. Each of these then is responsible for converting the value to a string in the way that it can for that data type. So for a string value, I'm just returning the value. For an integer, I'm doing integer to string, doubles to string, and time to string. This particular statement, void value, is intended to handle cases where you might have stored object pointers in the KeyValue pair. It will return an empty string, which is not much use for transferring to the remote machine, but at least it will avoid crashing the application if you do happen to have stored a value pointer. So those are all the functions in the base class. Now, by declaring a base class, I can then declare this value as type KeyValue Pair value base. I don't need to add a type definition in here, because everything that is a typed KeyValue Pair value is also a KeyValue Pair value base. Alright, so now that I have that, and this is my KeyValue Pair class, I have a constructor, and again, I have to template the constructor. I'm not templating the entire. Let me remove that. I forgot to remove that line earlier. There. I'm not templating the entire class. I'm only templating the value type passed into this KeyValue Pair constructor. So it takes a string of a key of type string and a value of some type. Then I have a destructor, and then I have a functions to get the key, get the type, get the value, set the value, which means I can overwrite the value with a new value, and convert to string. So let's see the functions that I have for those. First, the constructor, and that's a simple assignment of the key to the internal key variable, and then I'm calling it the set function for the value. That's the same set function mentioned above, so I'm reusing that to set the value. The destructor is simple. I need to just clean up the value because that's an object variable. I need to clean that up if I'm going to terminate this class. The getKey function is very simple. I'm just returning the key variable. And the typename function is also simple because I've already declared a typename function as part of the value class or part of the KV pair value class. So I'm just calling that function and returning that in the getType function here. The get function does require templating because I need to know, or you need to specify the type of variable that you're going to return from the get function. So this is a templated function returning a type of t-value, and in here I need to cast the m-value variable to the type that you've specified using t-value. So this statement here, and I've added some extra spacing in the parentheses to make this easier to show. This is the cast. Inside parentheses I've declared CKV pair value t-value asterisk, meaning it's a pointer to a CKV pair value t-value class type. So that casts this m value to that type, and then I'm just calling the get function on that, and then I return that value. So when you do use the get function, you do need to know which type of value you're getting, but that makes sense because you're going to have to assign it to something. Then the set function, again I'm using templating, but because you're passing the value into the set function, I'm able to get the t-value from the type of this variable that's being passed in. So there's no need to specify that in the set function when you make the call. So then all I'm saying is that if m value is null, or if it's not equal to null, so if it's already been assigned something, then I'm just deleting that object. And then I'm simply creating a new m value of type CKV pair value, specified that type name, and passing the value into the constructor. And then the toString function, again I'm just calling m value toString. So now let's just see if all of that compiles. I'll go back to the test script and use this and see if it compiles for us. Here in the test script I've included the kvpair.mqh file. I'm declaring a pointer to a CKV pair type object. I'm using the constructor where I'm passing in a key, and in this case I'm passing in a string value to set this up first time. Then I'm reassigning an integer to that same pair, and then I'm reassigning a double to that same pair just to test that this works. Let's run the compile first. And now I'm getting this deprecated behavior message. And that's easy to fix. Under MT5, let me find it. That's coming from this statement. All I have to do to fix this is to explicitly specify the parent class name. If I do that and come back here and compile, that goes away. So that's the first of the changes that we need to make for MT5. And fortunately, this change is completely compatible with MT4. So this MQH file can be used in both MT4 and MT5. Next to the telemetry class. And this class has three purposes. It stores an array of KeyValue pairs. It's able to save that array to a file and retrieve the array from a file. So here I've declared an array of KeyValue pair types. I have a function to delete rows, which is a way of cleaning up everything that's in here. It simply deletes everything in this array of rows. Find key, which is used when we want to set a value for a key. I need to find which element of this array has that key. A constructor and a destructor. The set function, which you'll remember in the KeyValue pair, takes a value. So here I'm templating this to get the type name. The get function, which is also templated and uses that type name, plus a default value to return a value. And then the save to file and load from file functions. So let's see these functions here. First the constructor, I'm calling the common base constructor first, and then just deleting all rows in the constructor. That just makes sure that the array is initialized. The destructor also just calls the delete rows. I'm cleaning up all of the objects before we delete this object. The delete rows function is fairly simple, just looping through all of the rows, calling the delete statement on each of those elements, and then I'm resizing the array to 0. Save function, passing in a file name. I like to set a specific value here, so if this isn't already in the array, I'm going to set it here in the telemetry class, and it's the time that this file was saved. And that just helps if you're reading the file on the client computer, you can know exactly when this was set, and it's good to use as a heartbeat, or just, if nothing else, to know that the file is current. And then these are standard functions. I'm opening a file as a type CSV, read and write, and it's comma separated, so that returns a handle. As long as that handle is valid, then I'm looping through the rows, and for each row I'm just calling the file write function, passing the handle, and then because it's comma separated, I pass each of the columns as a separate value. So I'm using the get key function from the KeyValue pair, the get type from the KeyValue pair, and the toString. And then finally I'm flushing all of that out to the file and closing it. And of course, if the handle was not valid, I'm just going to return false, and I'll return true if it was successful. The load function, again, I'm just opening up a CSV file, comma delimited, retrieving a handle. Then I'm calling the delete rows function to initialize the array. And as long as I'm not at the end of that file, I'm reading each of the values from each column, the key, the type, and the value. They've all been stored as a string in the file. And then I have to convert each of those values to its appropriate data type. So this is why I've stored the type in the file. And if the type is a string, then I simply set key. I'm calling the set statement for key and value. If the type is an integer, then I'm converting that string value into an integer first. If it's a double, I'm converting it to a double first, and if it's a date time, I'm converting it to a time before calling the set function. The set function is a little further down. And then I simply close and return true, and if I was unable to load, then I'm going to return false. And here is the set function. It's templated, but it gets the template type from the type of the value. So if I've passed in an integer, this will simply be an integer. And then all I'm doing is calling the find key, so I can find the appropriate key in the array if it already exists. If the array, or if the key already exists, then index will come back as greater than or equal to 0, and all I'm doing then is calling this set function of the KeyValue pair object to set that value. If I don't find that key, then I'm going to add a new row. So all I'm doing is resizing the array and then assigning a new KeyValue pair to that element of the array. The get function, I'm also using the find key to find this key that was passed in. Once I have that index, I'm just using the get function from the KeyValue pair to return the value, and I'm passing this default value, which does two things. It helps to set the type on this get function. Otherwise I would have to use this type of syntax to specify the get, but I don't know what I'm getting, so I'm relying on the default value being passed. And if it doesn't find a value in here, it will return the default value. And this is where I'm returning the default value if that key was not found. And then the find key function, I'm using a very simple linear search, just looping through all of the rows in the array, and if I find a row that has that key, then I'm just returning that index, otherwise returning a -1. Now I said that if I cut this back to the basics, then it would be easy to convert to MetaTrader 5. And by cutting that to the basics, what I mean is I've included common functions and common base here, which are actually not used inside the telemetry class. I've included them because I typically inherit from common base, but I'm going to remove these just for the time being. That means I'm going to comment out those two include statements. I'm going to remove the inheritance here from the class, and in the constructor I'm going to remove the call to the common base constructor. So now let's go to the test script and just see if this compiles. In the test script now I've included the telemetry file, and I've added these statements to create an instance of the telemetry class, and then I'm setting my key to firstly a string, then an integer, and then a double value. Let's just see if this compiles, and I get some errors, and these are the next three of the changes that need to be made. This function, str to integer, to double, and to time, no longer exist in MetaTrader 5. But the alternate functions are just string to integer, double, and time. And those functions also already exist in MetaTrader 4. So again, if I compile now, no problems. So now that small change has made this file compatible with both MetaTrader 4 and MetaTrader 5. And that's all I needed to do to convert the telemetry to work with MetaTrader 5. But I'm also going to go through what it takes to include those common base classes that I removed, because that shows some of the techniques of converting other code to MetaTrader 5. First, let's put these statements back. And now if I go and attempt to compile, I have a lot of errors. Let's start with the common functions. If I just run the compile here, you'll see that I have a whole series of errors relating to things like market info, which was a function that existed in MetaTrader 4 but no longer exists in MetaTrader 5. It has been replaced by several different functions depending on the information being returned. Now I still want to maintain compatibility with MetaTrader 4 and MetaTrader 5 in one file. So what I'm going to do is create some functions for compatibility purposes. Let me just do that now. You might prefer to put these compatibility functions in a separate file, but for the time being I'm just putting them inside the common functions file. The compiler defines these macros, double underscore MQL4 double underscore, and the same for MQL5. So I can tell which version I'm compiling for. So by including this block of code inside an ifdef MQL4, these lines get included if I'm compiling MQL4, and these if I'm compiling MQL5. So these were the functions that were causing problems inside the common functions file. Market info, trying to get the ask price, the bid, number of points, and digits. I've now defined functions that return those values: ask, bid, point, and digits. And in the case of MQL4, I'm calling these market info functions, which existed in MT4. But for MQL5, I've replaced them with these newer functions: symbol info double, again just returning ask, bid, point, and digits. So what I need to do then within the rest of the common functions file is replace any instances of market info, mode ask, bid, point, digits with these function names. So let's go through and do that. And now that should compile. And it does. So that takes care of the common functions. If I go back to my telemetry though, I'll find that there should still be a problem. So let me go and recompile here. And this is inside the common base class where I have this market info call to determine whether trading is allowed. This function, the bool trade allowed function that I have in the base class, has nothing to do with telemetry. It's just a standard function that I've included in my common base class. But if I'm going to inherit from common base, even though that function is not being called, I still need to make sure this compiles. And I'll also go back to the compatibility functions to create a compatible function for trade allowed. So here the trade allowed function under MetaTrader 4 was, as we have in the class already, the market info function. But in MetaTrader 5 it uses this terminal info integer function to determine if terminal trading is allowed. Now I have to point out here, MetaTrader 5 operates differently to MetaTrader 4, and this may not be the only thing you want to check if you want to trade under MetaTrader 5. There are also functions that tell you what type of trading is allowed. But for my test here, I'm just making something that's compatible that simply tells me whether basically the market is open. So with those functions in place, I can now go back and modify common base here. And I'm just going to return the trade allowed symbol. And that's already a Boolean function, so that should be fine. Let's try this. I have to replace digits here as well. Right. Deprecated behavior function again. I'm returning trade allowed as a function, and this is the same name as this function name, although they're obviously different functions because one takes an argument and the other doesn't. But this is the same thing that we saw in the KeyValue Pair, where I had to qualify it with the parent class. In the common base though, there is no parent class. This is just a function. So I can just add 2 colons here. And that's fine. So now let me just go on and show you a sample EA that is going to use the telemetry and a sample indicator that will read the telemetry at the other end, and then we'll do the demonstration on that. Now just to run this through a demonstration, I've created an expert advisor, which I've called does nothing because it doesn't trade. It just goes through a loop and stores information which could be sent to a client computer. And then I've created an indicator called also does nothing that reads that information on the client computer. So this expert advisor, I've simply included the telemetry NQH file, specifying a file name where the information will be saved. And remember, because this is inside quotes and the backslash is an escape character, I'm using 2 backslashes to indicate a path delimiter on Windows. I'm setting a variable of type C telemetry. And before we go much further, I've added some extra functions to the telemetry class just for use here, but you might find other uses for them. So let's go to telemetry class quickly. And these are my functions. Count, which simply returns the size of the mRows array. Then get key for a given integer index. Get type for a specified key. And toString, which returns a single value to a string. Let's see the functions for those. Right, so get key, as long as the index is greater than or equal to 0 and less than the size of the mRows array, then I'm just returning the get key function from that KeyValue pair. And for get type, I'm doing the find key search on the specified key, and as long as that returns a value, then I'm just calling get type on that KeyValue pair. And toString, same as the get type, I'm just finding the key and then returning the toString function from the KeyValue pair. So back to the expert advisor, I'm creating an instance of the telemetry class, and then I'm setting the timer to 30 seconds. So I'm going to cycle through every 30 seconds. The information that I'm going to store is just an example here. And on dinit, I'm deleting telemetry because I'm cleaning up the object. And then each time the timer runs, I'm calling a set function. Let me show that quickly. The set function I've put here because I want to not only set the value in the telemetry class, but I also want to print the value that I'm setting. So I'm passing a key and a value into the set function, which is the same key and value that are then being passed into the telemetry class. So I'm just setting a name, and here I'm getting the expert name using the chart get string, and this function won't work in MT4. There is a different function for that. But this is just the example expert. Then I'm passing in the current bid and ask prices and getting the available memory from the server. Then I'm calling the save function to save that to a file. And because this save function sets a time current, I'm again calling print format for the current time after calling that save function. So these will just come out in the log files. The indicator, which is meant to be run on the client, also does nothing. Still, including telemetry, the same file name. Calling this show telemetry function, and again I'm setting the timer to 30 seconds. So every 30 seconds this will refresh the information on the client computer. And the show telemetry function here, I'm calling the load function on the telemetry object, passing a file name, and then I'm simply looping through for the number of elements in telemetry, retrieving the key, and then simply printing the key and the toString value from telemetry for that. So if I run the expert on the server and the indicator on the client, we'll be able to see the information being stored on the server as it prints these statements, and we'll be able to see the same information being retrieved on the client. Before we run this, I'm going to show you how I, in this case, move the information from the server computer to the client computer. I covered this in the earlier video for MetaTrader 4, and there is no difference in the procedure, so I'm just going to copy that piece of video back in here. I have two virtual computers running here, so things will be a little bit slow. This is my original demonstration computer. That's going to be the server for MetaTrader, and this is the client computer that I've set up to show that we can retrieve the information from the server. And to do that, I'm just going to use Dropbox. So let's have a look at the Dropbox folder first. Here's Dropbox. I have nothing else in here. And let's open Dropbox now on the client computer. And you can see here, this is the demo client. And on this computer, this is the demo, which is my server. So I'm going to create a folder here, which is my telemetry folder for sharing information. Now I'm using Dropbox. You can use any cloud sharing application that you like. Let's create the new folder first. Right, so there it is on both computers. Now I need to move the file from MetaTrader through that shared folder. I'm going to start up MetaTrader. As I said, this is a little bit slow, so I might just skip part of the video here while I load MetaTrader on the two computers. Now I have MetaTrader loaded on both computers, and I've used File Open Data Folder to get to the data folder. So here in the MQL folder on my server computer, I go to the Files folder, and this is currently empty. Here, and the Files folder, and this is currently empty. MetaTrader by default will only write data, or read data in fact, into the Files folder inside MQL4. So I don't have access directly to the Dropbox folders that I've set up. I could use DLLs inside my applications, but I'm trying to do this without using a DLL, So I'm going to use a little bit of trickery instead. So just if I create, or let me go back to MetaTrader here, and if I run the test save script, run that, and then go back to the folder, you see it's created the telemetry folder with the test CSV file in here, but nothing appears over here. So what I want to do is have this file created inside Dropbox. Let's go back to files, and I'll delete that for now. So I'm going to use folder linking. So on Windows, open the command prompt, and you want to right click this and select Run as Administrator. You'll need the administrator privileges to do this. Or on Mac or Linux, you'll be opening the terminal. Now I'm going to navigate into this folder, and rather than retype this string, I'm just going to click here, Control C to copy that, go to the terminal, CD and Control V to paste. That puts me into that folder. To move this data into Dropbox, I'm going to use the mklink command on Windows. If you're on a Mac or Linux, you'll use ln-s, and I'll leave you to investigate the syntax for this. But for Windows, the syntax is mklink/d, because I'm creating a directory link, the name of the folder that I'm creating in this folder, telemetry, and then the path that I'm going to link this to. And because I'm on Windows, I'm going to use the environment variables to find Dropbox. And that Dropbox/telemetry is the folder that we created earlier. There's symbolic link created. If I go here and look at my MQL files, you can see telemetry, and it has this little glyph showing in the corner of the icon. I'm going to do the same on the client computer. I'm just going to pause the video while I do that and then come back. Now on both computers, the demo, which is my server, I have the telemetry folder, and on the demo client I also have the telemetry folder, and both of those point into the Dropbox folder. In fact, if I just go there to Dropbox. Now if I go back to MetaTrader and I run this test save client again, put that away, you can see this test.csv file has been created inside Dropbox, which is the same file as the MQL folder. And if I now go to the client computer, there is the test.csv. As I've done before, I have two virtual machines running, the server and the client. I'm going to run the expert on the server, and then I'll run the indicator on the client to show the transfer of information between the two. So first let's start the expert on the server. I need to allow algo trading, and I also need to allow algo trading here. And now I can see this is sending information. So on the client machine now, I can load in the indicator. And this is retrieving information. So it's retrieving the same memory variable that was set. The time is the same. So I'm actually transferring information between. And you can also see I've used two demonstration accounts here. I've used a different account number on the server and the client, just to demonstrate that you don't need to even use the same account, and there's no reason why these can't be a mixture of MetaTrader 4 and MetaTrader 5, given that the code runs on both. I hope this has been useful to you. If it has, please leave a like, and if you would like to see more videos like this, remember to click the subscribe and the bell icon to be notified when we release more videos. Thank you for watching.